Hey guys, it's Pt.2 back at it with another video. This week, let's square up. Again. Let's get it. So this is my part 2 to the squaring up video. So I won't be going over anything I did previously. That's gonna make this video too long. Instead, I'll put a link to that video in the description below, and that way we can get on to writing the program for this. So one thing I forgot to mention from last week's video is that we need to put a loop interrupt here, or else it's not going to exit this loop and move on with the rest of the program. So I'll add that right here, there and there, in the program. You should be good to go. And now it'll move across into this area. I'll put another comment to mark the fine adjustment stage. It's not necessary, but you can just keep it right there if you want it to help you mark things out. And I'll also put a debugging tool. So I'll grab out an LED display and I'll set it to the color red this time, and that'll tell us we're in the fine adjustment stage. This is when I originally wrote the program, this helped me fix errors and things like that. Now we're gonna grab a loop, not switch. We're gonna grab out a loop, and we're gonna be doing a lot of math operations with the variables we have. So brace yourself for that. Anyway, we'll set the exit case to this loop with its time, and we'll set the time of this with duration, the variable duration we created in the beginning of the program, if you remember from last week. So when the user uses this MyBlock, they can just input the duration of whatever they like, keep it to read numeric, and plug it right in like that. So now we're gonna grab this move tank block, set it to on, and we'll be plugging in all our math operations into here, but not just yet. First we're gonna grab two math blocks, set them both to advanced. I'll copy paste them here. That annoying thing's right there. Can't get it off my screen right now. And we're gonna grab out a few more variables. So I'll grab speed. I'll grab out KP. We'll need that. We'll also grab out an average variable. And we'll all set them to read numeric. Now the equation we're going to set into these advanced blocks, I'll explain it why it works later, but just know that it's D minus A minus B times C, and put it all neatly in brackets. Now you might notice we're going to be using this in a future video. Actually, we'll be using equations similar to this in a lot of videos. It's very useful for making corrections, and I'm very proud of discovering it. So we'll copy paste that same equation into here. No, it actually doesn't change from minus to plus, as I'll explain in a later video. It actually is minus and minus, or plus for both of them, and that's because unlike a line follower where we'd be making corrections in the horizontal direction, we're making corrections in the vertical direction here, and we want to have each of the light sensors control the motors independently. If you don't understand what I mean, that's fine. I'll be more thorough about that in a future video. Anyway, we plug each of these into their respective math blocks, their respective motor powers. Now we're going to grab a color sensor, two color sensor blocks, set them both to compare reflected light intensity, and set them both to wire so we can customize which port we need. And then we can grab out 2 more variables. I know, this program has a lot of variables. Set one to right light sensor port, and set the other one to left light sensor port, and set them both to read numeric so we can draw the values from them and plug them into the measuring. Oh, did I set it to compare? I meant measure reflected light intensity. There, that's it. And we can keep this in the A input for the respective math blocks. Now average is going to be the B input. Just keep it ordered there for both the math blocks. I'll expand this loop out, it's kind of getting cramped. Speed will be the D input. And KP will be the C input. So now you can see all that's changing is that we're making an entirely different math block just because we need to accommodate this extra sensor. It's a slight inconvenience. And that's basically you got the program written. Now all I'm going to do is explain how and why the program works. So here I have the sketchpad open, and apparently this is what I call drawing. Whatever this is supposed to represent. It's supposed to look remotely like a robot. These are the right wheels, left wheels, powered by the motors, and this is the left light sensor and the right light sensor. Here's the equation that we use. It should actually be plus instead of minus. I accidentally have the sketchpad open right over here, and this is what I call drawing apparently. It's supposed to represent a robot with these 2 black gear things supposed to represent the left wheels, and these 2 supposed to represent the right wheels, and this red dot is supposed to be the left light sensor, and this right dot is supposed to be the right light sensor. Anyway, here's the formula for the motor power as we use in the program, and these are the 4 values they represent, and these are the examples I'll be using for their values in this little mini lesson. Anyway, let's imagine that this robot is at an angle and it's approaching the line, the black line, just like that, when suddenly the left light sensor senses is less than its threshold, which is 50, for example here, the average light value. Now, all we need to do is plug in this formula. Actually, this is supposed to read D plus. I made a mistake in my program. Anyway, 50 minus 30 is negative 20. And then we've kept KP as 1, just to simplify things. So that's still negative 20. And then D is 0. So 0 plus negative 20 is negative 20. So we just keep this going at negative 20. Whoops. But you get the idea, hopefully. Basically, the robot has to turn left a little bit, which is the correct correction it needs to be making. But it's still not done, because now that that's at about 50%, the right 2 wheels still need to power forward, the robot fully turn. And how the robot determines that is, well, 60 minus 50, which is what the right light sensor is sensing right now, is 10. 10 times 1 is still 10. And then 0 plus 10 is still 10. So, pretty simple. It turns a little more that way until it's exactly 50%. Now, in the rare case it overshoots, it simply repeats this process from the other side. We can imagine, let's say these were flipped around, it would simply do the same in the reverse process. Now that is if the robot is stopping for the first part of the line over here. If it's to the front part of the line is where you want to correct, then you simply change this to D-, and you can understand why that would work, hopefully. Basically, it's making corrections in the opposite direction as it was previously. So now, if one is sensing 30 and the other sensing 60, instead of making a negative 20 correction and a positive 10 correction for the respective motors, it's making a 10 correction and a negative 20 correction. I'm not going to go over that just for the sake of time, and this video is very long, as I've said earlier. Jump to finishing the rest of this program. So now that we have our program completed and we understand exactly how it works, both the fine adjustment and the gross adjustment stage of the program, all we have left to do is make this into a nice SMI block. So let's get that created. Let's zoom out until we can see the entire program. Yeah, I know, it's a pretty big program. Probably one of the bigger ones I've made. Yeah, you want to grab everything except for the start button. That's why you can't just Control A. That's a bit tedious, but whatever. Go to My Block Builder. How about we call this Square Up? What the heck? And then let's add a light sensor icon. And now let's add 1, 2, 3, 4, 5, 7, 8, 8 different parameters. Yeah. So let's have one for the left light sensor port, and I can call it that. It's going to be set to input, because you're inputting information. This is the parameter cell, or text input, because it could be anything from 1 through 4. Let's keep the default value at 1. It'll be a number as a data type. That's pretty much how it's going to be for all of them. Just keep it at the default unless I say otherwise. So we can keep it like that. That's the port symbol. Same for the other one. Let's just do that first. Call this the right light sensor port. Bad spelling. Let's have one for normal speed. Sorry, starting speed. And of course, let's keep it at the vertical slider, since it can't be beyond 100 or negative 100. Also, data type is a number, and the starting speed can have this power symbol. And since we don't know what power it'll be, we'll keep it like that. Now we'll have our normal speed. Or no, still not yet. We need to have our duration variable, how long it's gonna be. Same thing here, and the symbol is gonna be a clock with a timer. Timer 1, right like that. Now finally we're gonna have our normal speed. Same thing, vertical slider. We'll have the same symbol as before. With the question mark and the power symbol. I hope that you guys get where I'm going with this. KP, same thing. I'll keep it with the same icon. I don't know what to put for that. I'll keep an average one. And as the icon, I'll have the threshold symbol. That's right here. Average, 50-50. And the last one is going to be our low variable. And the reason we're looking for when we're line squaring is because in case of an FLL mat where there's already other low values to mess you up, especially this year's Into Orbit where there's a very dark mat, it's very useful to look for the low value, and that's this low symbol over here. Let's finish that off and just simply plug in the parameters. Just waiting for that to load. Okay. So the left light sensor port goes into the left light sensor port. Pretty self-explanatory. Do the same thing for all the variables. Uh, very simple. You can order them however you like. Cosmetics doesn't matter in programming. And that's it. We can Control S, save that, and our program is completely finished. Let's check out the my block, or whoops, that's my old version of this. Let's check the square of my block. Now the entire thing is compressed into this really nice my block. See how all the parameters are right there, and we can easily use them however we want. I can put 2 for this, my specific information. Starting speed of 30. The duration I would recommend from 1 to 3 seconds, depending on your accuracy and how much time you need. For FLL, where there's a big time crunch, I would recommend a smaller duration. Normal speed is 0, KP at, I think, 0.5 should do the trick. Average for my bot is 35. Low is 8 for my settings. Now let's download the program and let it run. Thanks for watching, guys, and if you enjoyed the video, remember to like, comment, and subscribe. If you want to see more awesome tutorials like this every single Friday, remember to ring that notification bell. Okay, see you next week. Bye.